Welcome back, everybody. As promised, these are the notes for dilations, something that we started in the earlier video. But the objective for the day is to be able to find dilations on the coordinate plane. And I kind of introduced this with basically a Joey and his amazing gun that could shrink things at first and then enlarge things. Those were all kinds of transformations called dilations. But just building upon our list here, these are the types of transformations we've done thus far. We talked to reflection. Again, how a reflection is just a flip on the coordinate plane. In order to flip, though, you need a line. So these were common lines that we used. Then a translation. Remember, translation was just a slide on the coordinate plane. And remember, we did that using coordinates, words, and vectors. Then we looked at rotations. Rotations are just a spin on the coordinate plane. So you're just taking a figure and spin. You need a point that's the center of rotation, and everything else either moves clockwise or counterclockwise around that. And then these were some common rotation degree measures that we looked at. Then we spent a day and we looked at symmetry. Again, there's basically two types of symmetry. You got reflectional or line symmetry, and then you have a rotational symmetry. And I illustrated that with different polygons, so on and so forth. But today we're going to add to our transformations. Again, these are all transformations up here. This was just a characteristic. And then we're looking at dilations today. Dilations, the definition of it is a transformation. And this is the first time it's not an isometry. And the reason it's not an isometry is because the pre-image and image end up being similar to each other. Similar. So down here is kind of an example of what I'm talking about. Again, this being the pre-image, this is the image. Again, if I go pre-image to image in this direction, this would be an example of an enlargement. And then this one, I start with a large pre-image to a smaller image, that is a reduction. So again, this is enlargement. And this is a reduction. And those are the two dilations we're going to look at today, enlargement and reduction. A dilation is a transformation whose pre-image and image are similar and they're not congruent. That means it's not an isometry. Dilations always have a center, which is a point. The scale factor is basically a ratio. It's the same ratio we looked at in similarity. The scale factor for dilations, though, we're going to use the variable n for. And like I said, it is a ratio, which means it's a comparison of two values. So in this instance, n is going to equal the image measure over the pre-image measure. So it's always image over pre-image. So keeping that in mind, so this would be over pre. So image over pre-image. If the dilation is enlargement, again, the pre-image is smaller and then the image is bigger, that means this number on top is going to be bigger than the number on the bottom. That means the scale factor is going to be greater than 1 because the larger number of the smaller number. So this would be greater than 1. If the dilation is a reduction, again, now your image ends up smaller than the pre-image, so this measurement's going to be smaller than this one. That means it's going to be less than 1. So down here again, you can tell which is the pre-image into the image because of the prime. The larger safety pin here is the image, this is the pre-image, and the center is at C. So again, the center is always a point. I like to think of the center as if you throw a rock into a pond and it makes the ripples come out from where that rock hits the water. Where that rock hits the water is the center. So again, you got to think of that and then the ripples coming away from it. So this being the center here of the dilation kind of ripples away from it. So this corresponding measurement 12 would go over the corresponding measurement of 8. So the scale factor here would be 12 over 8 because the image has to go over the pre-image. So I can reduce that and take a 4 out of both of those. So that goes down to 3 over 2. So the scale factor is 3 to 2. And since it's larger than 1, it's an enlargement. Over here, again, I see the P prime is here. That means this is the image. This is the pre-image. Centers at happening at C again. That's where the rock is hitting the water. So my image measurement would be the 18. And now so the image measurement goes on top of the pre-image measurement, which in this case is that 30. And so now I can take a 6 out of both of those. So that goes down to 3 to 5. And again, that's less than 1, and anytime it's less than 1, then it's going to be a reduction. So those are the examples of the two dilations that we're going to look at. Down here, again, the center's at A. Imagine that's where the rock is hitting the water, and everything's kind of ripple away from that. Here I see the primes on this. That's the image, so it's getting larger, so it must be an enlargement. So I need to come up with a scale factor. Well, if these are all congruent, the B to B prime would be 2 of these congruent lines. So it would be 2 of those, whatever the measures are, over the image measure, or the pre-image measure, which is just 1 of those. So that's going to be 2 to 1. Over here, again, look at the primes. The smaller images in here, so that's a reduction because it's getting smaller. And then it gives me a distance. The distance from O to A is 5. So that's the pre-image measure there. And then the O to A prime is 5. So that's from here to here. That's to the image. So that's the image measurement. And then O to A is the pre-image is 15. So it'd be 5 over 15, which is what, 1 to 3. And again, it makes sense that it's less than 1 because it is a reduction. So down here, it asks you to draw some dilations. A dilation is a similarity transformation that enlarges or reduces a figure proportionally. Determine whether the second figure is a dilation of the first. If so, give the scale factor. So the second is a dilation of the first. This would be an enlargement of what, 5 to 3? So enlargement 5 to 3. This over here would be a reduction. So this is a reduction. That would be what, 3 to 6, which is what, 1 to 2. Then over here, this would be 4 to 6. So if I take the smaller side, that's going to be 4 to 6. I'm going to make sure this is similar figures here. So this is me checking to make sure that the ratio is the same. So that goes down to 2 to 3. And then I go 5 to 8. Well, that does not reduce down to 2 to 3. So because of that, this is not a dilation at all. Simply because these ratios are the same, which means they're not similar figures. And I know that dilations have to make similar figures. So down here, find the scale factor for each dilation. Again, the primes are letting me know that those are the image points. So the pre-image points are the non-prime ones. So here again, I notice from A prime to B prime, that is a distance of 2. So it's an enlargement, so that would go on top of A to B, which is just 1. So again, this is an enlargement 2 to 1. Over on this one, looks like another enlargement here because these are the primes and they look bigger. Let's see if I can find match pair up of measurements. So I'll use B to C because they look like I have measurements on them. So since it's enlargement, I'm going to use the image points here. 1, 2, 3, 4, 5, 6 over the pre-image 1, 2, 3, 4. So that is an enlargement 3 to 2. Enlargement 3 to 2. So that's how I do those. Over here on this next one, to draw the dilation here. So dilate triangle ABC. This is my pre-image with a scale factor of 2.5. So this is the first time I had to do this. So the first thing I'm going to do is I'm going to come up with the ordered pairs for A, B, and C. So I'll do that real quick. It looks like A is happening at what? Negative 1, 2, 2. So negative 2, 2. So that's where A is sitting. B looks like it's at 1, 0. Oops. C is at what? Negative 2, 0. So those are the pre-image points. So now when you want to find the dilation and they give you the scale factor, all you have to do is just multiply each of the values by the scale factor. So I'm going to take the negative 2 and multiply it by 2.5. So you just do negative 2 times the 2.5. And to do that, I end up with negative 5. So that's all I'm doing to come up with those image points. This would be what? Negative 5, comma 5. B is going to be at what? 2.5, comma 0. When I multiply each of those times 2.5. Then on this one, this would be at negative 5, comma 0. So I've got my image points. All I got to do is graph them now. So point A here is at negative 5, 5. So let's see, negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's my one image point. That is A prime. B prime is going to be at 2.5, 0. So let's see, 2.5, 0 is going to be right about there. And that's my B prime. And then negative 5, 0, that's going to be over here. And that'll be my C prime. So that's drawing an enlargement, basically. Again, the trick was just multiply the pre-image points by the scale factor. So this ends up with my dilation right here. Again, it's enlargement, so it makes sense that it's larger. So down here, it gives me some more. I'll probably continue with these on the next video. Again, my timer's running out here, 15 minutes. So I'm going to pick up on these two problems on the next on the next video. I'll talk to you then.